So I'm going to be recording this meeting because some students reached out and said that they could not make it, but they really wanted to get the video afterwards if possible. So that is an excellent idea. All right, guys. I hope everybody's doing okay. We're going to get right into it. The first problem from last week, 1 out of 5, reads as follows. You can see it on the screen. Please read along with me. If you want to volunteer to read, please unmute yourself and you can volunteer either problem 1, 2, 3, 4, or 5. Here are the heights of a sample of 17 adult males: 73, 71, 80, 78, 66. By the way, I read it because I expect you guys to copy all these numbers in a piece of paper, okay? 64, 75, 79, 63, 70, 77, 61, 69, 74, 72, 67, and 76. Draw the histogram for these data, okay? So very straightforward. They want us to draw a histogram. All right, I'm gonna change the screen. So, and then after the question, you had these histogram space to kind of draw the data. So we're gonna start by analyzing the information that we were given. So we noticed that from the numbers that we just reviewed, hopefully everybody has those numbers in a piece of paper, we do have 4 intervals of equal size. We do have the interval from 69 to 75, and it's already given to us because all of these horizontal line is being given to us. So we have 4 intervals of equal size. So we go ahead and review all those numbers that I read out loud that you put in your paper. And we realize that we have 5 values that fall in the interval 69 to 75. As simple as that. So 73 is one of them, 75, 72, 70, and 69. So because there are 5 values that fall into that interval, you guys grab your cursor or your little arrow in your computer and you click as close as you can to the 5 in the frequency over here. Let me see if I can use a pointer just to make sure. Site control. So that is for the first interval. Okay, we need to do the same thing for the second interval, which is 76 to 82. So we do have 1, which is the 78 over here. 2 over here, the 76. And I don't know if I miss anything, but I miss 1, of course. So there are 3 values. The 3 values that fall into the interval 76 to 82 are 78, 80, and 76. So those are the 3 values. So we go ahead and draw the second histogram for the second interval. In the same way, we go ahead and review the data. We do have 3 values that fall in the interval 83 to 89. And then finally, we have the last interval from 90 to 96. There are 6 values. If we want to make sure that our answer is correct, we can add 5 plus 3 plus 3 plus 6, and the number should equal the number of values that we were given. Okay, so I'm talking about all of these values: 96, 92, 89, all of those. Okay, so that confirms that our answer may be correct. Okay, this is problem number 1. Any questions? Please take a look at your notes. Please unmute yourself if you want me to go back to any specific information. All right, let's move on then. Second problem. Remember, if you would like to read out loud, you can volunteer to do that, but I really don't want to put anybody in the spot. So if nobody volunteers, I'm gonna read the problem. But while we wait for any volunteers, please write this down in your paper. You can use your own words. Take your notes, your own style, okay? 9 adults were asked how many different jobs they have had. Their answers are listed below. 5, 7, 2, 2, 4, 4, 4, 4, 4. Our job is to find the range and the mode for the data, okay? That's what we are going to do. Find the range and mode for the data. First, what is range? Please copy this down if you could. The range tells us how much the data are spread out. Okay. And we're gonna review the formula. This is very important. If you write it down, then you don't have to overload your brain trying to remember formulas. The formula for the range is the greatest number minus the least number. So in this case, we must find the greatest and least numbers in the data. The data set is 5, 7, 2, 2, 4, 4, 4, 4, 4. From there, please take a close look into that data set. The greatest number is 7, and the least number is 2. That's all we need. So the range equals 7 minus 2, which is 5. Once again, this number 5 is telling us how spread out are the numbers in this data set. All right. But we were asked for two different things, range and mode. Let's find out or remember what the mode is. The mode tells us which data value occurs the most. All right. When I was in high school, like you guys are right now, I was going to high school in Spanish completely. Mode translates literally to moda in Spanish. And that word is used to define somebody that is always on point. Like in Spanish, I would say, Miss Boren is always a la moda because she's always wearing nice clothes, like very current, very modern. So just kind of a little bit of background if you guys were getting lost or losing interest. But mathematically, the mode tells us which data value occurs the most. I have a hard time pronouncing occurs, okay, because of my accent, but it's basically what value is seen the most. What value do you see the most? Let's go ahead and review the values. We have 7, 2, 2, and 4, 4, 4, 4, 4. If you lost track of how many times I was saying 4, I said 4 5 times. You see it on the screen. So very easy. There's no addition, there's no subtraction, there's no formula. Just by looking at it, we see that the mode is 4. We go back to the problem. We make sure that we are answering the question, which is finding the range and mode. So the range is 5, the mode is 4. I'll leave that there just for a few moments. Please examine everything on the screen. Compare it to your notes on your paper. Make sure that you understand what happened from one step to the next. I'm not checking the chat right now just because I don't want to be confusing, but I mean, I don't want to confuse myself. I am so sorry that I cannot kind of handle both things at the same time, but please excuse me if I'm not responding right away, okay?
Carlos has been giving some right answers about the mode and the range, I think, but no one else is chatting, so I've got you.
Thank you, Ms. Boren, and thank you, Carlos. You absolutely did those calculations correct. I appreciate you sharing your answer. Ask me anything. All right. Ask me any questions. Take a look at your papers because I took the problem away. And if you're a little shy, once I'm done with the 5 problems, you can stay at the end and just tell me, Mr. Escamilla, I wanted to tell you about problem 2. So if that's your case, write your question down on the paper and we're going to talk about it at the end. Let's move on to the next problem. So the students that I have a lot of 79s, a lot of 75s here in this group. So I want to recognize your incredible performance, guys. You fell just a little tiny short from the score that would not require you to be here. I don't want to say passing or not passing. Okay, that's not accurate. So because of that, I'm going to go a little faster because a lot of you already got these problems right. Third problem, it's about mean and median of a data set. We continue to work with data sets. We need to get used to that. Take a look at the problem, copy, paraphrase the problem, read it to yourself. Each of 6 students reported the number of movies they saw in the past year. This is what they reported. 9 movies, 17 movies, 12, 4, 14, and 20. Let's please stay focused. These are 6 values that 6 different students reported, okay? Please stay with me. I know this is not the most exciting information that I can share with you, but we need to go through it. So please stay with me. Ask questions. Be proactive if you feel like you're losing interest. And if you got this question wrong, of course. We need to find the median and mean number of movies that the students saw. If necessary, round your answers to the nearest 10th. This is very important. We're going to revisit that to make sure that we report the answers to the nearest 10th. They're talking about approximation. Let's start with the median. What is the median? Okay. I went on Alex. I read the definition that you guys get when you are taking the median and mean topic. So the median is a value that divides the list in half. As simple as that. So we have 6 numbers in this list. We have 9, 17, 12, 4, 14, and 20. Well, if we want to start working with these numbers, please write down that the first step is to order the numbers. We need to order the numbers from least to greatest. Let's do that. 4, 9, 12, 14, 17, and 20. Those are these 6 values. So here, I really want to highlight the importance of knowing how to get the median when we have an even number of data set, okay? If it was an odd number of values, an odd number in this list, we would just go right in the middle and select that one, and it was the end of the story. We found the median. But because it's an even number, what we need to do is this. Here's the problem. I just put the same thing that the same analysis that we did together in the previous slide. And here's the process that we do when we have an even number of values. In order to find the median, we need to add the 2 middle numbers, 12 plus 14, and then divide that by 2. 12 plus 14 is 26. 26 divided by 2 equals 13.
So you got 5% now.
That is the median. Now we're going to work with the second part of the question. We need to find the mean. Here's a reminder of what the mean is. The mean is the sum of all those numbers divided by the total number of values that we had. In other words, the sum of 9 plus 17 plus 12 plus 4 plus 14 plus 20. Please go ahead and help me out. Thank you, Carlos, for sharing your answer. I really, really appreciate it. And I'm sorry again for not seeing your previous messages. All right. Hopefully you guys got 76. That is the sum of all of those values. But now we need to divide the sum by the total number of values, which is 6. 76 divided by 6. That's the next step. 76 divided by 6 is 12.666666, and it goes on and on. We need to round to the nearest tenth after the decimal point. One position to the right to the decimal point is the 10th position. And we were asked clearly to round to the nearest 10. So in this case, we look to the right of that 10th position. We do have a number 6. If the number is 5 or greater, we round up. If the value was, it is not, but if it was 4 or anything less than 4, then we ignore it, dismiss it, and we leave the answer as 12.6. But in this case, it is 12.6. All right. So here's the problem. Originally, we went over every single word in this problem, and here's the answer that we came up with. After doing all those calculations, remember, you do these calculations on your own, and then you go into the window and you make sure that you enter the answer. Some people go really fast, and if you enter 12.66666 for the mean, that will be marked wrong. If it was Mr. Escamilla grading your work, I would mark it right. Trust me. But unfortunately, we are using a system that grades everything way quicker than I could ever do it. So please make sure that you go back, revisit the problem, and make sure that you are entering the answer the way it was asked. Let's just take a moment to just see how we're feeling, to see if we are still in the mindset of continuing. Take a deep breath or just simply relax there for a moment. So we give everybody a fair chance to fully understand how to find the median and the mean in a problem like this. All right, let's move on to the next one. And this is the problem that is gonna start challenging you all, okay? We are building up the level of difficulty. So please make sure that you take a moment to read the entire problem. Come up with ideas, even if you don't know or you don't remember what to do. Think about what you would do if this was a question in the state test or in the STAR test or in your Alex knowledge check. What would you do? That's going to promote your curiosity, your natural curiosity as a human being. We're very curious creatures. Here we go. A bag contains 19 cards number 1 through 19. A card is randomly chosen from the bag. What is the probability that the card has an odd number on it? Write your answer as a fraction in simplest form. Let's go over the explanation. First thing that I notice is that there are 19 cards. 10 of them have an odd number. Let's just make sure that I'm not overlooking anything. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19 are the odd numbers. So we do have 10 odd numbers and 9 even numbers in that 19 card deck. Each card has the same chance of being chosen, all right? This is what probability is like. We analyze the probability of an event to happen, okay? So the probability of choosing one is 1 divided 19. the probability of choosing the number 13 is 1 divided 19. All right, but that's not the question that they asked. So we have to keep looking. Here's the formula to find the probability of an event. And I want to take advantage to remind you all, especially if you are not in good terms with functions, because functions can be very polarizing. So it's completely normal if you don't like functions. But that's not an obstacle for us to actually learn the topic and get it out of the way. So when you see P parentheses and then a label inside close parentheses equals to, I'm basically reading these mathematically, okay, guys? You can always remember that when you see this term in math, even when this is not a function, well, it is a function, but for the purpose of the lesson, it is not. So we read it probability of choosing an odd number, okay? That's the intention of using all of these symbols. So the formula that we're going to use is we're going to divide the number of cards with an odd number divided by the total number of cards. This formula is not universal. I want you to know that. We review the formula for the range and the way that we find the mode. When it comes to probability, it is not possible to give you a general formula. You always have to read the problem. For this specific problem, the probability is going to be the number of cards with an odd number divided by the total number of cards, which is, we have 10 cards with an odd number, and we have a total of 19 cards. So the probability is 10 over 19. We need to write the answer as a fraction in simplest form. We cannot simplify this any further. Carlos, I'm going to address your answer in a moment, okay? At the end. I'm not ignoring your question mark. All right, so 19 is a prime number. It's okay not to know which numbers are prime, okay? It's perfectly fine, but I really expect all of you to understand that a prime number is a number that cannot be divided evenly by any other number besides itself. 19 is one of those numbers. It's a prime number. So whenever you get a prime number, either in the numerator, where the 10 is at, or in the denominator of the fraction, then that is your clear sign from the universe. The universe is sending you a message. You cannot simplify that any further. So 10 over 19 is the simplest form. Are there any questions about this problem? Are there any questions about this problem? You guys are awesome. Thank you so much for being focused. I cannot thank you enough. I'm so grateful to work with a group of students that is just so respectful. It's just very, very easy to go over this content, but I'm gonna flip it around. I started with a compliment, but now I'm going to challenge you. If you don't have your camera on, if you are not asking questions out loud, take a moment to make sure that you are taking notes, that you are engaged. Otherwise, you're gonna have to keep repeating this topic until you kind of see the different steps and figure out what's missing. And that's my job to help you, by the way. So figuring out what you need and what you need help with is not just your job, but it's our job together. All right, so nobody's asking questions. Let's go over to the next problem. Here is when the probability and statistics probably scare 80% of all students. And I would even dare to say all people, because this problem is going to become a monster. However, we are talking about a dice. So we do have used those dice to play. So now we're just basically entertaining our brains. We are forcing our brains to kind of think of a problem that involves probability. So please pay close attention and stop me at any point if you lose track of what is going on. An ordinary die is a cube with the numbers 1 through 6 on the sides. And there's a picture of 2 dice here. So imagine that such die is rolled twice in succession, meaning one after the other, and that the face values of the 2 rolls are added together. So in simpler terms, if you roll the dice and then you got 5 and 4 in a succession, then you would add 5 plus 4, which equals 9. That's what they mean by added together. The sum is recorded as the outcome of a single trial of a random experiment. Here's our job. Our job is to compute the probability of each of the following events. Event A. Good news, we don't have to write all of these inside of the parentheses. Remember, we just reviewed the probability formula. Instead of just finding the probability of the sum is greater than 9, we're just gonna write the probability P parentheses A close parentheses equals to. And then after we're done with that, we're going to find the event B, the probability of event B happening, which is the sum is divisible by 4. They're making it complicated. Of course, there's 11th graders here. So we need to kind of keep pushing to problems that challenge our knowledge. All right, let's start by analyzing this chart that I found. I did it and I pasted it here. This chart or this table is showing the 36 possible pairs that can result from the rolls. I really want you to please notice absolutely everything in this table. So the probability is that you can get 1 the first time and then another 1 for the second time, or you can get 1 the first time that you rolled it and 2 the second time that you rolled it, or 1, 3, 1, 4, 1, 5, or 1, 6, because you only find numbers 1 through 6 in these fair die. I always said dice. I don't know if I'm incorrect, but all right. But another possibility is that you get number 2 and then 1, or 2 the first time and 2 the second time. 2 the first time, 3 the second time. 2 the first time, 4 the second time. So by looking at this pattern, I created this chart that allows us to see on the screen what we are already thinking. That's why I gave you a little bit of time to kind of read the problem and think about what you could do. Actually, I didn't give you time for this problem. I'm sorry, I gave you time for the previous problem. So gonna go a little slower. Please, this might be the reason. No, this is the reason why a lot of 70s are here. So please make sure that you are challenging yourself. All right. By challenging yourselves, I mean, pay close attention. All right. See exactly where you missed the problem last week. All right, let's do this thinking, okay? I was last night trying to use mathematical language, but still kind of explain why we do what we do in this type of problem. So the first analysis that I did last night to kind of explain it to you guys is that because the die is fair, meaning that there's no tricks, okay? In mathematical problems, they always use the word fair because there's some people that have gone to Las Vegas with special dies that just promote a certain number. So there's tricks. So they always use the word fair just to explain that there's no tricks in this experiment. Each of these 36 pairs has the same probability of being rolled. For example, the probability of of any number of any addition being added is 1/36. 1 because it's just the sum of one number, and 36 because 36 is the total possible outcomes in this experiment. That's why I put this chart here. If you were wondering, why is it 36? Where did that 36 come from? Let's move on to the second part of the analysis. The sums of the numbers making up the pairs are the outcomes of interest, meaning we need to now examine that chart, evolve that chart, and then find the pairs that we are interested in, okay? Because depending on their sums, I didn't put the definition here, but the sum is basically this adding two numbers together, just the way we did these 5 and 9 over here, okay? So 5 and 4, 5 and 4 is over here. If you see column, before column, 1, 2, 3, 4, and then you go down here, this is the numerical representation of this happening, of rolling a 5 first and rolling a 4 after, okay? So now that we kind of understand the problem, now we need to do the work. From that chart, I'm not bringing more charts, okay? I don't want you to get overwhelmed like, oh, what happened there? This is the exact same chart. All I'm doing is highlighting the events that give us the sum of 2. The sum, okay? Or adding 1 plus 1 equals 2. There's only one. You can see it highlighted in yellow. There are 2 ways to get the sum of 3 because you have 1 plus 3 when you roll 1 first and 2 second. And you also have the sum of 3 when you roll 2 first and 1 second. Then you can look at all the other cells. There's no other 2 numbers that add up to 3. In a similar way, there are 3 ways to get the sum of 4. Just, you guys start seeing a pattern. There's like a diagonal shape that tells us that there are 3 different ways to get the sum of 4. One way is rolling a 1 first and a 3 second. Another way is to roll 2 first and a 2 second. And a third way is to roll 3 first and 4 second. All right? There are 4 ways to get the sum of 5, and you can see it over here. Examine this chart, please. Take a look at every single highlighted cell and make sure that you understand what this is helping us with. We are thinking about it, and sometimes we need to see it because there's too many numbers. Okay? All right? So there are 3 ways to get the sum of 10. I jumped from the sum of 4 to the sum of 10 because we're gonna start addressing the question in the problem. If we go back to the problem, event A is that the sum is greater than 9. So the sum greater than 9 is 10, 11, and 12. All right? So going back to this, there are 3 different ways to get 10 as the sum of the 2 numbers. So the first one that I put here is 4 and 6. 4 plus 6 is 10. The second one is 5 and 5. 5 plus 5 is 10. And the third one is 6 and 4. So 6 plus 4 is 10. We also have to do the same thing for 11. In order for us to get 11, we could get option A, 5 first, 6 second. Option 2, we could get 6 first, 5 second. There's no other way to get the sum of 11. Finally, there's only one way to get the sum of 12. Let's not forget we are talking about dice. So if you are thinking of the probability of adding the 2 numbers to 12, there's only one way. You have to get 6 the first time and you have to get 6 the second time. So the probability of event A, this is the meat of the sandwich, okay? Or this is the most important part of the problem, in other words. The probability of the sum being greater than 9 equals to the probability of the sum is 10, the probability of the sum being 11, and the probability of the sum being 12. Here on the left, you see where these numbers came from. The probability of the sum being 10 is 3. The probability of the sum being 11 is 2. The probability of the sum being 12 is 1. 3 plus 2 plus 1 equals 6. Notice that we are putting that plus sign in between of those. Over here in the formula, if you just copy the formula, it's not telling you that you have, it doesn't give you the plus sign because it's using the word sum. S-U-M. I don't know if I'm pronouncing it perfectly correct, but I mean sum, S-U-M. All right, so the probability is 1/6 for event A, and the event B, just as a reminder, is the sum is divisible by 4. This is making it more complicated, but not too complicated. It's just a little more complicated than A, but the sum that can be divided or is divisible, just to use the words that Alex is using, the probability that the sum of those two numbers is going to be divisible by 4 is whether the sum is 4, the sum is 8, or the sum is 12. If some of you are just wondering how did he so quickly went and knew that it was the sum of 4, 8, and 12? All I'm doing is using multiples of 4. 4 times 1, 4 times 2, 4 times 3. And then when I go in 4 times 4, 16 can never be the sum of two numbers after rolling fair dice, okay? So I didn't put the charts here, but you guys can, even when it's not highlighted, there's 3 different ways to get the sum of numbers 4. We can see them here. 2 and 2, 1 and 3, 3 and 1. Okay, that's where the number 3 came from. There are 5 different ways that the sum could be 8. And there is only one way that the sum would be 12. All right, we have it here. It's the very last one over here on the right. Only one way. So we conclude that our answer is the probability of the event A is 1/6. The probability of the event B is 1/4. I took a large step, so let me just backtrack a little bit. 3 plus 5 plus 1 equals 9, divided by 36. 36 because there's 36 total possibilities. That's what I put that chart there, so you can visually confirm that there's nothing more than 36 options when we roll a dice twice and we add those two numbers. So 9/36, there's no prime numbers in there, so I know that 9 and 36 are both breakable into factors of 9 times 1 and 9 times 4. So when we cancel the 4s, we end up with 1/4. And not too bad. I calculated these lessons to last 40 minutes. And it lasted almost exactly 40 minutes. My invitation for you is to please remember that next week we have the 5-question pretest, a different topic. Try to plan a day ahead. Ms. Bourne is being extremely helpful. We are a team. I couldn't be happier with the team member that I work with in this session. She sends you emails, and I asked her as a favor yesterday to remind you, logging into your Alex regularly. Talk to your lead teacher about Alex. Your lead teachers have access to your login name and password. And guess what? If they don't have access to your login name and password, they're gonna let me know, and I'm going to make sure that that is available to both you and your lead teacher. Okay, you guys are wonderful. I cannot thank you enough for giving me the time to help you. Now is your turn. Okay, it's your turn to do exactly what we did. I was talking about if you are shy and you didn't want to raise your hand or ask questions when everybody was listening, now everybody can go ahead and get started in their Alex. I opened the assignment at 10:30. That's why, Sean, you had to wait a little bit. Thank you so much for your patience. So now you guys go and practice this and feel good with yourselves. And even if you score low for what you are expecting, because there's no expectation. The expectation was for you to show up and you did. So thank you for that. Now, The only expectation is for you to learn from the mistakes that you made last week. Even if the mistake was no rounding up that 12.66, even if that was your only mistake, that is a very small mistake that you can learn from. Slow down. Read the question. It is better to take an extra 60 seconds reviewing your answer as opposed as not getting the credit that you deserve. You're gonna go into your